Hi there again. In this session, we are going to be introducing ourselves to databases. So we are going to be looking at the basics of databases and try to understand the nitty-gritty of what a database is. So at the end of this video, it is expected that you should be able to describe the differences between data, information, and knowledge. You should be able to understand the basics and concept of a database system. You should be able to understand the various types of databases we have. You should also be able to understand what an entity relationship diagram or an ERD is and what it does. And lastly, at the end of this video, you should be able to understand what primary keys are and what foreign keys are. So, before we go ahead into databases, let's see why we need databases in the first place. So, the goal of many information systems is to transform data into information that gives some sort of insights that can be used in decision making. An example is a food company, for example, that takes data of all its customers and their orders and transform that data and get some useful insights that would help or improve their business performances from those data. So that's majorly why we need databases. So in order to do this now, a database system must be able to take that data, put the data into a context, and provide tools for aggregation and analysis. And databases are designed just for this. Now, what's the difference between data, information, and insight, for example? So data are raw bits of pieces of information with no context at all. An example would be the numbers you can see: 15, 23, 14, 85, Lagos, Kaduna. Those are pieces of data, and on their own, they make no sense really. And just hearing them, you probably can't make any sense of them. But if I give them to you, I would have given you data. So, like I said, by itself, data is not useful. So, to make data useful, it has to be given context. So, let's look at the example above. Again, we mentioned 15, 23, 14, and 85. So, if I told you that 15, 23, 14, and 85 are the number of students that registered for some courses in a class, then that would be information because I've put that number in a context, added context to those set of numbers. So now you know, oh, 15 students registered for this class, 23 students registered for this class, 14 students registered for this class, 85 students registered for this class. And that's putting it in a context. It's converted that raw data to useful information. So now, when we have useful information, the next thing to do is to do analysis on our information or our data in a context to generate some sort of knowledge or insight. So, for example, if I took that particular data, number of students that registered for a course over certain years, I could do some aggregation and find out, oh, over the past 10 years, number of students that registered for data analysis class at an average or are increasing over the years or have been decreasing over the years, or we have an average of certain number of students per year, and that would be insight. That would help me make better decision having that. So that's the difference really between data, information, and knowledge or insights. So when we say database, what exactly do we mean by a database? So simply putting it, a database is simply a place where you can store, manipulate, or retrieve data. So it's sort of a repository for data. A data is an organized collection. Find it here as an organized collection of structured information or data typically stored electronically on a computer system. So that's one characteristic of the database. It must be stored in an electronic format in a computer system, and it must be structured, because in a database all data is described and then is associated with other data. So you have data associated with other data, so they are all interconnected, and that makes it a database. So let's look at the types of databases we have. Now, the first databases were formed in the 1960s, and then we started with the flat files, storing data in flat files databases such as the CSV format. From there, we progressed to hierarchical and network databases. But right now in the world today, there are mainly two main types of databases, and we have the relational databases, also known as the SQL database or the SQL databases. And then we also have the non-relational databases, also known as the NoSQL database. The NoSQL stands for not only SQL databases. So let's look at what these database types are. So we're looking at relational databases first. So relational databases. What is a relational database? So I said here that a relational database typically stores information in tables. So in traditional tables, we have all our data stored in tables that we are all accustomed to, the normal row and column tables. And then they contain specific types of data. So for example, like I've said here, a shop. So say for example, I own a store or a shop. I could store details of my customer names and addresses in one table. So I could call it my customer table. So on my customer table, like you can see here on the screen, I could have different fields. I could have my customer ID. So that's not having an ID for each customer. So Adamu is customer 1, Musa is customer 2, Brian is customer 3, etc. And I could have a field for their first name, for their last name, for their address, and for their country. I could also have another table that monitors my daily orders or my daily transactions. So on that table, I could have my order dates, my customer ID. So on this day, on the 1st of March 2022, customer 1, like we said, is Adamu on the customer table. Purchased product name, product XXX at price XY. And those are two tables. And when I connect those tables, remember we said in the database, data is connected. So when I connect those tables, this is in its simple form a database. So this form of data storage is often called structured data. And this is basically the system that forms the relational databases. So let's look deeply into relational databases. So, like I said earlier, they're also called SQL databases because they use the SQL, which stands for Structured Query Languages. Now, in relational database design, the database usually contains tables, like we said before, which consist of columns and rows. Now, when a new data is added, a new record is inserted into the existing table, or a new tables are added. So, for example, I have 3 customers at the start of my business, and then all of a sudden I gain one more customer, and I have to enter his details into the customer table. So that's entering a new data or entering a new record into an existing table. Or for example, I can come up with a new table for suppliers. So where I put records of my suppliers. So I get a new supplier from UK that supplies me shoes. It's going to come into my supplier table with all its details. And then relationships can be made between 2 or more tables, and that's what makes those group of tables a database when we have relationship between table A and table B and table C. Now, the relationships that I speak of are in terms of common columns. So we relate 2 tables by the common columns in the database. So for example, looking at our example we are going by, where we have a customer table, where we have each customer details, the customer ID, the first name, the last name. So the first table shows us the details of our customers, right? And the second table is a table that shows us the details of every sale we make, right? So first table, customer A has first name, this, last name. So let's give real life example. Say customer 1, first name is Ayo, last name is Joseph, address is Ogumosho, country is Nigeria. And then on the other table, I would have order date, maybe 1st of March 2022, customer ID, customer 1, product name, maybe a laptop, and price, maybe 100,000. So you can see that on each table, we have customer ID being the common field in both tables. And this is the key where we join both tables. So it's on this basis that we join both tables. So what this means in layman terms is when I see customer 1 on my order table, I can come and check my customer table and search for who is customer 1, and then I can see that his first name is Ayo, his last name is Joseph, he lives in Nigeria in Ogbomoso. So that's basically how we join. We join using the common columns, and this is going to take us to talk about keys, because those columns are called keys. So this is going to take us to talk about keys, and basically we have two types of keys in database. We have the primary key and we have the foreign keys. Now I defined here that the primary key is a column whose values uniquely identifies every row in a table. Now let me break that down simply. On a table we have any column on a table that defines a specific row or that is unique for each row in that table is the primary key. So for example, if we look at the table below, we can see department ID and department name. So when we see department ID 10, what we are saying, we know automatically that department name is administration. When we see department ID 20, we know we are talking about marketing. When we see department ID 30, we know that we are talking about purchasing. And when we see department ID 40, we are talking about human resources. So these numbers in the department ID column define which department we are talking about. So a perfect example would be your student database in school, where every student has a unique matric number. That's like a perfect example of primary keys. So if I'm having a database of all the students in maybe Department of Computer Science, and every student has, no two students has the same matric number ever. Even if you have the same first name and the same last name and the same middle name, the differentiating factor will be your matric number, and that is the primary key on that database because it is unique for each person in that table. So even if you have the same first name, last name, gender, and maybe address, you can't have the same matric number. So primary keys are unique to each row in our table. Now, when we have a primary key, we can't have null values, and null means it can't be empty, really, because we need it to define a particular row in a table. So we can't have a primary key column empty in a database. And then a table can only have one primary key, really. So now we understand what primary key is. Let's look at what a foreign key is. So a foreign key really is a field or a column in one table that refers to a primary key in another table. We need an example to understand that. So let's look at the second table in this example here. We have two tables here. We have department table and we have employee table. Right, so our first table is our department table, where we said department ID is the primary key, right? So 10 represents administration, 20 represents marketing. But now this is a much more bigger table here. We call the employee table. Now, the employee ID, we have three fields or three columns in this table: employee ID, first name, and department ID. So employee ID, we can already tell the employee ID is the primary key in this employee table because it's unique for each person. Stephen is 100, Nina is 101, etc. But then when we have department ID in this particular table, department ID is the primary key on the department table. But when the department ID comes to another table, it is seen as a foreign key. So in layman term, a foreign key is a key on a table or a column on a table that is a primary key in another table. That's the layman explanation. A column in table B that is a primary key in table A. And that's the layman application, the layman definition. So now, if we want to link these two tables, we're going to link them on department ID because department ID is the common column, right? And then a primary key here is going to link the foreign key here, and hence we have a database because two tables are interconnected. So the table with the foreign key is always called the child table. The table B is always called the child table. So this is the child table. And then the table with the primary key is called the reference to the parent table. So in this case, this is the parent table, and in this case, this is the child table. So now that we understand the concept of keys, primary key and foreign keys, let's look at ERDs, or entity relationship diagram. Now, what are ER diagrams really? They are a pictorial representation of the data that describes how data communicates or they are related to each other in a database. So when we have a database, we have some simple database that have two tables and then they're just connected. We have some really complex database that have hundreds of tables that are all interconnected. So basically what an ERD, what an entity relationship diagram does is that it helps us visualize how all the tables in our database are related to one another. So the ERDs have three components. They're made up of entities, which are the tables we have in our database. The different tables in our database are called entities. Also attributes, and those are information that we need to describe each table, and then relationships, so how each table are linked together are the relationships. Let's look at a practical example of an ERD. So I further explained here, I said the entities are those tables in our database. So in this particular database, if you see the example on the right, we have 5 tables. We have asset types, IT assets, asset inventory, employee asset, employees. And those are my entities. Now, my relationships are associations between each table. So it shows how each table are related to one another. So we can see that the primary key on the asset type table is linked with the IT assets table because we have asset type code by the asset type code. So you see asset type code is a common field between these two tables. So we have types of relationships. We have one-to-one, one-to-many, and many-to-many. And their symbols are seen here. So for one-to-one, it means one occurrence of a field on the primary table would lead us to one occurrence of a field in the secondary table. So the attribute lastly are the columns we have in this table. An example is for asset types. You can see we have 2 attributes: asset type code, asset type description. So in the next video, we'll be creating an example of a database, a small database, just to practicalize. So see you in the next video.